Okay, so hopefully everybody remembers some of these fundamentals, but it's okay if you don't. We'll go over them today. So we talked about the time value of money, and we talked about variables that you needed to be aware of. So we talked about N, we talked about I over Y, PV, PAT, and FV. If you're scratching your noggin, that's okay. We're going to talk about what each of these means one more time. So N is a variable that stands for the number of periods. Okay, and in finance, this can represent a lot of different scenarios because the time value of money function uh, can be used in a lot of different scenarios. In this class, we're only going to look at personal finance situations, but it actually can be a lot of different scenarios. But for the purposes of this class, it will most often be pay periods or compounding periods. Okay. Um, Pay periods if we're making a payment on a loan, compounding periods if it's an investment that we hope to grow. So hopefully that's enough um, summary information that you can at least understand what that variable stands for. I over Y is the interest rate that we are quoted, but when we work with it, that interest rate is often going to be provided as an APR, and we must convert it to the periodic rate. And you might recall that we did that in our credit module, where we were taking APR that was given to us by credit card companies, and we were converting it to a periodic rate. I'll remind you all how to do that. PV stands for the present value. So the present value, really, there's only two scenarios that you would see in this class. It would either be the present value of a loan, which is the current loan amount, or principal, right? Or it could, if we're talking about investing, it would be the current investment amount, which is still a principal amount. Payments, PMT stands for payments, and it's very important that you understand that this variable, it cannot represent uneven payments. It has to represent an annuity stream when we're talking about the time value of money function. And so we did talk about what that was. I think it was in either module 1 or module 2, what an annuity stream is. It was one of the terms that we discussed. But if you're rusty on that, an annuity stream is an uh, even set of cash flows. Okay, so it's a recurring payment or a recurring allotment into an investment. Okay, and then FV was the future value. So in most cases, we want to know what something's going to be worth at a future point in time. So the value of a loan or investment, at some point in time in the future. All right, does everyone remember this? When we did like a fundamentals of time value of money at the beginning of class, and we talked about these different variables that you needed to be aware of and understand. And then I think I remember saying, like, we're going to come back to this in the accelerated course. We come back to it very quickly, but in the 16-week class, it takes a little bit to come back to these things. So I just want to make sure that everyone remembers these variables. So this is the time. Let me move this down. This is the time value of money uh, variables that we need in order to um, we need these in order to use the time value of money equation in Excel. We need to have these 5 variables. We have to define them. Every problem that we ever come up on, we have to define these. And the rule is that if you know 4, you can always find the 5th. It doesn't matter, which one's missing. As long as you know 4 of them, you can always find the 5th. Okay. I'm not getting a lot of feedback. So is everybody kind of remembering this? I know it might be a little rusty. I know it's been a little over a month. Okay, thank you. Well, let's just look at an example. I know it's hard to speak in hypotheticals. So this is just an example. This is not a car buying example. I wanted to start easier to begin with. Okay. So if you wish to accumulate $100,000 and your goal is in 13 years, the question simply states, how much would you have to deposit today into an account that pays on average an annual interest rate of 14%? This is a very simple time value of money problem. And what I'm going to do is I'm going to leave uh, this little legend, if you will. I'm going to leave it here so that you can see it. And I'm just going to copy this and bring it down. And we're just going to walk through this problem and we're going to identify our variables. Okay. So if you wish to accumulate 140,000 in 13 years. So remember, N represents the number of periods. All right. And so right now, that's a time variable, right? It's the only time variable that we're dealing with. And so anytime you are given in a word problem a specific amount of time, that's going to likely go with N. Now we may need to redefine N, and we'll talk about situations when that happens. But for now, I just want you to get used to assigning your variables. You're going to type 13 years, and I recommend that you put 13 in. If you're using Excel, then put 13 in its own cell and put your out to the right so you can use it mathematically. If you're using a calculator, then you would just, you would probably be using a piece of notebook paper and you'll just say N equals 13. Okay. And it says if you wish to accumulate 140,000 in 13 years, which means that I'm assuming that 140,000 is my future value. That's my goal. So let me just get this back to where I was. So my future goal is 140,000, and I believe what I was about to say was that it's saying how much do I need to deposit today, and since that's the question, that means the question is what is the present value of my loan need to be today, right? When you hear that buzzword, how much do you need to deposit today? That's like you know, a bell should be going off in your head. That's the present value. In order to reach that savings goal with an annual interest rate of 14%. So I'm hearing that my interest rate is 14%. What I'm not hearing from this problem is any mention of making future deposits. So this is a very simple problem because all I'm doing is I'm making a single deposit today and I'm letting it sit for 13 years. And so that means that I can zero out my payment stream. Okay, because there are none. And so now what I've done is I have identified 4 of 5 variables, and I've also identified the missing variable, which means now I can solve for it. So we did practice this a little bit before, but I know you might be rusty. Remember, there's a formula for each one of these. So whatever one's missing, that's the formula that you need to use. So if we're solving for present value, you would type in equals PV, open parentheses, okay? And then once you do that, Excel is going to prompt you um, to give it all the information needed to solve the problem. Now, what's really neat about this is that we've already defined everything it's asking for. So when it asks for the rate, you're just going to click that cell. When it asks for the number of periods, we're just going to click that cell. When it asks for the payments, you're going to click the payment cell. When it asks for the future value, you're going to click that cell. And when you get to that last option there, unless the problem states that interest is being compounded at the beginning of your periods, which is rare, most often it's not going to state that. We are just going to leave that setting set to 0. Okay. Once you have all of those selected and you've typed 0 in for that last option, you're going to hit enter. Okay. Whoops. Well, let's see what happened here. Oh, I know what I did. Sorry. So, made a very simple mistake in finance. Anytime you're given an interest rate, you must convert that interest rate to a decimal. So I need to make that 14.14. There we go. And there we have it. So if I want, and I know you're probably looking at this and you're saying, well, if you're familiar with Excel, you're probably saying, well, that's a negative value. How do you have a negative value? Well, it actually makes sense. If you recall, the time value of money equation requires your present value and your future value to be opposite of one another. And that's because they're not really positive and negative. What they are cash inflows and cash outflows. Okay. And so what the negative indicates in the time value of money function is that there must be an outflow, okay, in order to receive this inflow right here at a later date. Okay, so what this is saying to me is that I must deposit or have a cash outflow of $25,489.71 today into an account that earns 14% annually, and I must leave it there for 13 years untouched in order to achieve my savings goal of $140,000, which would then be an inflow to me because I would then retrieve it, which means the money is flowing back to me. It's flowing away from the bank back to me, but in order to do that, it must flow away from me originally, which is why this amount comes up to be negative. Now, if you're doing a homework problem, it's probably not going to ask you to enter a negative integer. And so an easy way to fix this to be positive is to just put a minus in front of your formula. If you put a minus in front of it, it does not impact anything going on inside the parentheses. So it's not changing your formula. It's just reversing your final answer. So your final answer will just come out positive. But for the math to work, one of these must be positive and the other one must be negative. So if you ever get an error, that's the first thing you should think. That should be your light bulb. It should be instantaneous, like, oh, maybe I didn't, have my positive, negative signs correct in order to get the appropriate answer or to get an answer. Okay, so that's just one example. Is this all coming back to everyone? Is this making sense?
Yes.
Okay, well, let's do an example with a car. So I'm going to hop back over. Let's see, where would it be? Here? Okay, so this was like just my little reminder from lecture. All right, so here's a very simple example. We're going to start out really easy. Okay, so we're looking at a car, and the price of that car is $15,500. And for very simplistic purposes, we are going to say that the interest rate is 0%. And the loan term is 5 years, but there's going to be monthly payments, so 60 months. Now, we even need the time value of money to solve this problem.
No.
We don't, do we? Because if interest is not involved, then this becomes simple math, right? Because we can actually just take the loan principal. So in Excel, we'd have to define it first. So I'd have to type in that 15,500, and then I'd have to type in the 60 payments, right? And then I would take that principal and I would divide it by 60. And so what I would pay if I wanted to pay this vehicle off in 5 years with a 0% financing, which means you're not financing at all, then I would be spending this amount per month. Okay, so this is just a simple example for you to realize that interest is the only reason why we need the time value of money function. We're not done yet, though. So let's type out our variables. I also want you to see the difference in payment. So I want you to visibly be able to recognize what financing does to a purchase decision. So I'm going to hop back over here just really quickly. Now we're going to do the same problem again, except we're going to do it with an interest rate of 2%. So now we're going to try this one more time, but we're going to do it by financing at 2%, which is pretty low. They must be borrowing from a relative. They might be. Okay, so again, we have to define in. Now this is where, remember earlier when we find our variables and I was reminding you about the definitions. Remember, it's the number of pay periods, not the number of years. So oftentimes what I see students do is they'll type in 5 years here, but it's telling you that there's going to be 60 payments. And so you must, like if you're given a problem where you're told that it's going to be a 5-year loan, but you're going to make monthly payments, you must convert. And the way to do that is to take the years and multiply it by 12. Okay. And so that changes your units as well. Okay. And earlier we talked about this also. You know, when you're given an APR, first we want to convert it to a decimal, but when you're in an APR, but you're told that monthly payments are going to be made, that means that that's an annual percentage rate that needs to be converted, right? It must be converted to a periodic rate. And if that sounds like a fancy word, really not. It literally means the interest rate that applies to the pay period. Because if we're making a monthly payment, we cannot be determining monthly interest using an annual interest rate. So we call it converting to the periodic rate because pay periods can change. It could be daily, just like with credit cards, but it could be monthly, like with homes and automobiles. And so we just use a all-encompassing term, periodic rate. Okay, so in this case, the periodic rate would be taking that APR and dividing it by 12, right? Because if we have an annual rate, I need to know how much interest to charge per month. So I have to divide that annual rate by 12 to see what the monthly rate would be. Okay, so far so good, hopefully. Now the present value, this kind of gets tricky for students because students say, well, I don't get that money. And I say back to them, well, actually you do. That money does not flow straight from a bank or a lender to the dealer. That money, even if it's, even if it's a microsecond, that money is yours. And you decide to spend it on that car. And so the car becomes what you get for it. Okay. And so when we talk about cash inflows and outflows, and remember, we're not talking about the value of a car, we're talking about the value of a loan. And so the present value of this loan is positive, and it's positive because it represents a cash inflow to you from a lender. Now, what you choose to do with it is up to you, and you have made the decision to buy a car with it. But when it comes to your relationship with the lender, the bank, okay, you received the money, okay, and you are going to pay it back with interest, okay? And so the question is how much are you going to pay back on a monthly basis? Now, here's an interesting variable that it seems like a lot of students always seem to struggle with. If the value of my loan today is $15,500 on a used car, and I agree to pay that loan off in 5 years or 60 payments, what is the value of the loan going to be in 5 years? What is it going to be in 5 years? If it's 15,500 today, what is the value of the loan going to be in 5 years? You don't need to be a finance professional to figure this one out. No, sir. It would not be worth that much in 5 years. What is the goal when you are a borrower? What is the goal as a borrower for any loan? What is your goal? Yes, Miss Ariel?
To pay it all off so the future value would be zero.
That's right. The future value, when we're talking about loans, not investments, but loans, the future value, the goal is for it to come to zero because the goal is to pay it down, to not miss a payment. And so anytime that we're talking about borrowing money and trying to, figure out, what the payment might be, or you might have a problem where they say, well, what interest rate do you want to get? The really neat thing is one of our variables is already defined when we start the problem. It's the future value because it's always going to be zero. Okay. So now what we have is we have 4 of 5 variables and we just need to find the last one, right? So, again, you might be rusty. So for this one, it's equals PMT for payment, open parentheses. And once again, we've clearly defined all our variables. And so we just give Excel the information it needs. So we'll go, rate in present value, future value, and then again, leave that type set to 0 unless you're instructed otherwise. And then hit turn or enter. And so what we get is we get a monthly payment. And remember, this is not technically negative. It represents an outflow because you're paying it, right? So the present value represents an inflow because the money flowed to you. That's why it's positive. And this value comes out negative because it represents an outflow. It's a that you are going to make on a monthly basis. And if we want to have that as a positive number to work with mathematically, all we need to do is just put a negative sign in front of it. That'll force it positive for us, but it'll allow the time value of money function to work appropriately. Okay. And so now the question is, we see the difference in payments, right? This is what a lender will do to you. So a lender might have put in front of you like 2% at a certain length of time, 3%, and so on, because they typically give you 2 or 3 options. I'm just going to give you 2 options for today, just for this one example here. So we have, this is this option here. I'm pasting the formula. There we go. And let's put this value right beside it. And let's make them both just in dollars. There we go. And so what a lender oftentimes or a financer will do is they'll say that, this is scenario A, this is scenario B. And what they'll do is they'll just tell you the margin. And we learned what was, right? The margin is what? We learned about margin, right, earlier this semester. The margin is a fancy word for the difference, right? Yep. Okay. And what they'll say is, well, the difference or the margin is only $13 per month. That's not that big deal. You can afford $13 more a month, right? And so what a lot of borrowers or consumers do is they'll say to themselves, well, yeah, I mean that's just like me and my significant other just cutting out, 1 extra meal a month. That's not a big deal. And that's the decision that they make. But what I want you to be is I want you to be more savvy about this. So we have 60 payments, right? So I wonder for scenario A, scenario B, what do you think the total cost difference is? Total cost. What do you think the total cost difference is? First, we might want to find what the total cost is in each scenario, right? So the total cost in scenario A, because we didn't finance anything, we would just take that payment, multiply it by 60, okay? and it will be the exact price of the car because we didn't finance anything. But let's look at total cost with the financing method. Now we see a difference, right? And so if we wanted to know what the total difference, the marginal difference between these two options, we could say, okay, what was the total interest paid in option? And of course, the first one, because we didn't finance anything, would be 0, right? But the second one, I can take that total cost to me and I can subtract the principal. And so I'll find that if I finance this vehicle for 5 years at 2% interest annually, and I make all my payments on time, that I'm going to pay an additional $800 across 5 years to own this car. So that means that this car actually got more expensive, didn't it? Because I'm not paying $15,500 for the car. I'm actually paying $16,300 for the car.